Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 671. Second minimum node in a binary tree. So we are given a non-empty special binary tree consisting of a node with non-negative value where each node in the tree has exactly 2 or 0 subnode. So which means what? Either 0 or 2 child. Now, if the node has 2 child, then this node's value is smaller among its any node of them. Okay, now it can be more formalized as root dot value is equal to minimum of the root's left value and root's right value. Yes. Now we want to return that special trees second smallest value. If there don't exist any second smallest value, then we want to return what? -1. So this is what the question states. Now, how to do this problem? So just come up with the solution. Come up with this example. So this is our first example. So from this tree, by seeing itself, we can say what is second minimum value. So my second minimum value will be what? 5. Because my first minimum is 2, right? So second minimum is what? 5. Okay. From this, there is only the first minimum. There is no second minimum, right? So I can say it as output as -1. And also, see the property. The root value is equal to minimum among the left side and the right side. See here, the left side of this 2 is what? 2. And the right side of this 2 is what? 5. So what is the minimum among this one? This 2. That's why its value is 2. And see here it is what? 5. 5 is the minimum value, right? That's why the value is what? 5. Hope you understand this. Okay, now, how to approach this problem? So just make this as a simple concept. Like, let me take array like this and put 2, 2, 5, 5, 7. Okay, fine. Now, let us take smallest and the second smallest as initially int max. So int max is the maximum value such that whenever I come up with a smaller value, it will be updated, right? That's why I'm taking an int max. No. I am at here. Okay. It is what? It is the same as the procedure of second smallest value in an array. So we want to find a second smallest value in an array. Okay. First it is 2, right? So 2 is smaller than the smallest, right? So I can say the smallest should be the second smallest. Updated. So it will be also in the max. And this will be what? 2 now. Hope you understand this. Now again. Now I'm going to this 2. Now my smallest is equal to this 2, and also the second smallest is what? Cannot be this 2, right? Second smallest cannot be 2. See here, smallest also 2, second smallest also 2. There is no logic, right? So what should be my condition? So smallest should be less than the current value, and also the current value should be less than the second smallest. Then only I want to update the second smallest. Okay, if the smallest itself greater than the current value, then what should I do? I should update my second smallest as yes, and smallest what? Current. So these are the two conditions as of now we have seen, right? Okay, then I can go here. So this is a 5. So 5 is what? 5 is greater than the smallest, and it is less than the second smallest, right? See here, greater than the smallest, and it is less than the second smallest. Update it. Hope you understand this, right? Now again, it is 5. It also not satisfied. 7 is also not satisfied because it is greater than both, right? So how can this 7 be my answer? Yes. So what's my answer? 5. Found it, right? So this is the array based. Now we are going to do this array based inside this tree also. Come up with me. Now see here. Initially I am at this 2, right? I am at this 2. Now see here. This 2 should be my smallest value, right? Should be my smallest value. Initially, what is my smallest value? It is also max into max, and this second smallest is also int max. Now this 2 is smaller than the smallest, right? So this second smallest should be updated as smallest, and the smallest should be updated as 2. Fine. Now we can do any other traversal. Pre-order, in-order, post-order, level order, anything you can do. Let's just take a simplicity for pre-order traversal. Okay. Now I want to go where? I want to go to this 2. Okay. Now whether it satisfies our condition or not. So we don't want to update it. Now it returns back and comes here. Now this 5. So 5 is what? greater than the smallest, but less than the second smallest. So this should be the second smallest. I did. Yes. Then I go here. And it also doesn't satisfy my condition. Then I go here. Then I go here. 7. 7 also not satisfy the condition. Go here. Backtrack. That's it. So it is easy approach, right? Okay. First of all, what is the time constant space of t? Time constant will be O n. Space of t will be O of h, where h is the height of this binary tree. Why it is h? Because it also requires the space, right? The recursion type also a space. That's why it is what? O of h, height of the binary tree. Now, it is what? First approach only. See here. Here we doesn't use any of this property. Okay. If in real time, if they are asked us to don't use this smallest and second smallest method, then we should use this properties, right? That's why I'm going to tell you the another method, the second approach. So let us think about the second approach. See here. Let us take, these are the examples, okay? Now, I am at this 2. Yes. So I can say, surely I can say root value can be equal to at least one of a child. Can you understand this? This root value can be at least one of a child, right? Can you understand this? Yes. Okay. It is what? It is if it has 2 child. Okay. If it has 0 child, then what should I do? It is what? It is a leaf node. It is what? It is a leaf node. So don't do anything. Don't do anything. I will tell you in this example. I will tell you. Okay. Now see here. At least one child. This value should be what? Root's value. So see here. This 2's value is equal to what? This 2. 2 and this 2 are same, right? So again, come here. This 5 and this 2 value are what? Not same. So I can say from this observation, this 5 itself greater than this 2, then how come this 5's child or 5's subtree can be a minimum, right? Can you understand this? If there are, take for example, here, what are the elements? 2, 5, 7. If this is smallest, take for example, then whether it is second smallest or this is second smallest, 5 is the second smallest, right? So we don't want to go beyond this. Stop here and just return 5. Yes. So what's the first observation? If any child node is not equal to root node, it's not equal to root node value, then just return that value. Okay, just return. Okay, hold on. Let us analyze still more. Okay, now here, if I go here, it is what? It is a leaf node. So beyond this leaf node, there is no value, right? No value. Okay, what is the value of this 2? This node value is 2, which is equal to this node, right? So this cannot be my answer. So if it is cannot be the answer, what should I return? I should return the -1, right? So just return -1. Okay. Now see here, it returns what? -1. It returns what? 5. So -1 cannot be my answer, right? Because I have 5. I have a better answer. So I should take this one. Can I understand this? Okay. Let us analyze the second example. If I am here, now I'm checking whether the root left value is equal to this root. Yes. So we may proceed with this children. But unfortunately, we don't have any children because it is a root node, leaf node. So it returns what? -1. Here also it returns what? -1. So both are returning -1. So I want to return what? -1 only. Don't hesitate. Just return. Yes, because it cannot form, it cannot have, or it didn't have any seconds minimum value, right? Okay, now come here. I am at this 1. Now I am going here. It is also equal to 1, right? It shows that its subtree may have a second minimum value. Okay, now I'm going to this 2. So this 2 is not equal to this 1, right? So going beyond this 2 is unnecessary. Take this as our answer. Okay, I will take it. Now, from this 1, I can say this 1 is my next equal value, but it is what? A leaf node. So I will return -1. Here it is also a leaf node. So I will return what? I will return 3 here. Can you understand this? It is not equal to. 1 is not equal to 3. So going beyond this, it's not necessary. So it's just written here. Because beyond this, what can be the value? It can be greater than or equal to 3 only, right? So I don't want to go beyond this. So I'll return 3. Now, -1, 3. What's the better answer? 3. So return 3. So 3 here, 2 here. So what is the better answer among this? 2 is the better answer. So what are the case we have encountered? We want to first traverse to the entire node if and only if, what is the condition? The left child is equal to the right child, right? So I want to find the left and right child. Okay. First step, I want to take a DFS traversal. Okay. And I can take a root node. Now, if the root is equal to null, then what should I do? If it is the case, then what should I do? I should return what? Just return -1. Just return -1. Then what is second condition? If the roots is a leaf node, it's a leaf node, then what should I return? I should return what? -1. Why we are returning the -1? See here, just take for example, if there are two roots, okay, if the root's value is equal to the child, then only it goes beyond it, right? Here also, it goes beyond it. Else, we will take direct sub. So I can say, whenever there is a leaf, it returns what? -1 only. Yes. So I will return the -1. Okay, now, then I'll assign L is what? Roots left. And R is what? Roots right. Fine. Now, next step, I should check whether we want to traverse to left or traverse to right. So what is the condition for traversing? If that roots value is equal to left, which means what? We want to go beyond that, right? Just take for example, it is 1. Here it is 1. Then here it is 3. Here it is 2. Here it is 1 again. Here it is something like 3 and 4. So from this 1, we want to go to this 1. Then we go further on it, right? But here I will take this 3 and return itself. Return this 3 itself, right? So that's why we are not going beyond it, right? So here we want to go beyond it. So I am take L is equal to DFS or just root dot left. That's it. So why I am taking this L is equal to? Because we may get the second minimum possible value from our left subtree, right? That's why I am making this recursion call. Now, if that root's value is equal to right value, right child, then R is equal to DFS of roots right. That's it. Yes. Take for example, for this tree, this subtree is not going to traverse, right? Sorry, not going to recursion call. So this 3 will be directly written, right? So that's why the 3 will be where on this R itself, and this will be not executable. I understand this? Yes. Now we want to check whether the both 3's value is not equal to -1. So L is not equal to -1, and also R is not equal to -1. Can you understand this? Let us take for example, it is something like 1, right? For 1, I say here also 1, here also 1. But here it is 1, but here it is 2. Here it is 1, here it is 3. So for this one, here it will be 2, 3. Here it will be return value is what? 2. So you want to take the minimum among this 2 and 3, right? That's why I want to take what? Just return min of L and R. That's it. If L is not equal, L is equal to -1. My left is equal to -1. Then what should I return? I should return the right. If my R is equal to -1, then what should I return? I should return L. Okay. If both of them are -1, then I should return any one of them. So it will be what? -1. So I can say this is the whole code for this approach, right? And then what is the time complexity space empty for this approach? I can say at the worst time complexity, it can be over n only. We are going to iterate each and every node. Just take for example, here 1, here 1, here 1, here also 1, here also 1, here 1, here it is 2. So we are going to iterate each and every node, right? Now, what is the space empty? It is over cuts. So these two are the time and space empty for this solution. Okay, let's see the code so that it's more clear. See here, this is a code for finding what is the smallest and the second smallest number by using what? The first approach. See here I used L, I put L, right? L is the smallest and SL is the second smallest. Okay, now float of infinity. I'm taking the int max. Now I'm going on traversing each and every node and I'm checking whether the condition is satisfied. Here I gave the condition, okay? If the condition is satisfied, I will do the operation store in what? L and SL. Okay, and I made that was enclosed variable. Both are enclosed variables, such that it will be updated like a static variable only. Now at last I will return SL if SL is not equal to float of infinity. Else I want to return what? A -1. Can you understand this? If it is a maximum number into max, then I can say it is not changed, right? So I want to return what? -1. You don't have any possibility. Let me submit it. Then over the cut பண்ணிடலாம். Yes, it is submitted fully. Now let's see the second approach. Second approach is the most important approach. See if there is no root, it is not root is equal to null, just say return -1. If it is a leaf node, then return -1. When this condition is satisfied, when this condition will execute, take for example, the root value is 2 and its child value is 2. Then only this child is leaf also. This child is leaf also. Then only this condition is satisfied. That's why you're returning what? -1. Yes. Now, L, R is equal to root dot left dot value and root dot right dot value. Now, if my root dot left dot value is equal to root dot value, then I will take L is equal to DFS of root dot left. Same for the root dot right also. Now, if both are not equal to -1, then I should return what? Minimum momentum, right? And if L is not equal to -1, I want to return L. Else I want to return what? R. Because L is not equal to -1 means I am returning L. If it is not the case, see here is what? L and R should not be what? A -1. If any one of them, which means if L is -1, then I should return what? Sorry, if R is -1, I should return what? L. If L is -1, I should return what? R. And also, R is what? -1 only in another case also. So I am returning what? Just R only. Now I am just returning what? DFS of root. Let me submit it. Yes, it is submitted successfully. Thank you.
And then, what do you feel?